it does not record audio, so I have to stop and start again. Okay, now it's okay. Good. So what does tangent equal to?
Sine over cosine.
So we are going to differentiate, and we're going to use the quotient rule. The denominator right away, because that's the easy part. When I differentiate sine, I get cosine. So I differentiate the top function to get cosine times the bottom function. Nice. And minus the top function times the denominator prime. But the denominator prime is negative sine x. Nice. So then, anyone remembers how much is sine squared of an angle plus cosine squared of the same angle?
1.
Thank you. Does anyone remember the formula 1 over cosine squared? What does it mean? Or 1 over cosine x first?
Secant.
Secant squared, very good. That's it. So then tangent prime is secant squared. Cotangent prime is negative cosecant squared. We can prove the other ones if you want. Secant prime is secant times tangent. And cosecant prime is negative cosecant cotangent. To be remembered. Okay, so let's choose. Let's go to 3.3. I can share my screen. So 3.3. The top exercises from 1 through, we already shown one of these. So 1 through 22. Anything, please choose. Anything.
22.
We want to start with 22. Perfect. So let me copy it, and then I'll stop sharing. Good. F of t, that's 22, equals t, e to t, cotangent t. Perfect example. And I'll show you why it's a perfect example. Well, I'm running into some difficulty here. Here's why. It was cotangent. I didn't copy everything. What was it? It was cotangent t, right? Yeah, I didn't copy that by mistake. Sorry about that. Cotangent t. Okay, here's my problem. 1, 2, 3. I don't have a formula for 3. I have a formula for 1 times 2, which is 1 times 2 plus 1 times 2 prime. First and then second. But that's okay. Here's what I'm going to do. I'm going to consider this 1. I'm going to consider this 2. So then f prime of t will be t e to t prime times cotangent t, and then plus t e to t times cotangent prime, which is negative cosecant squared t. So now I will apply the product rule again. So the first function prime is 1, so e to t plus t e to t prime, which luckily is e to t, minus t e to t cosecant squared t. And now I have to distribute, and it's done. E to t cotangent t plus t e to t, cotangent t minus t e to t, cosecant squared. So we don't think in terms of this formula, but what basically is this. 1 prime times 2 times 3 plus 1 times 2 prime times 3 plus 1 times 2 times 3 prime. That's exactly what this is. But there is no need to memorize something like that. Very good pick. Thank you. Any questions? Any questions? Would you like to pick something else? Would you like to choose something else? Anyone? Or I move on to a very important function to discuss. Anyone?
Can we do one more?
Yes, please choose anything you want. F of t, f of x, whatever it is. Please do.
Okay, so I have to get to the examples real quick.
Right here. I brought it up.
Oh, okay, sorry. I think number 20. Can I see number 20? Yeah,
Good.
number 20.
Perfect. Number 20. So number 20 is g of z. I will replace that z. You're not gonna. The way I write z is ugly, so difficult to read. So I'm gonna replace it by x. Same thing. So g of x equals x divided by secant x plus tangent x. Okay. Good. So we want to determine g prime. Obviously, we have to use the quotient rule on this one. So g prime. I will immediately write the denominator to get rid of it. So this is secant x plus tangent x everything squared. Now I know that the numerator has to have a difference, right? The top prime is 1 times the denominator minus the top times the denominator prime. Secant prime is secant tangent plus tangent prime is secant squared. I cannot do anything else but just distribute x to these two terms and leave it alone. So secant x plus tangent x minus x, secant x, tangent x minus x, secant squared x over this squared. Secant x plus tangent x. There is nothing else I can do here. Good. Anything else? Would you like to choose something else, or can I talk about a function? Any questions on any of this? Any questions? Okay, well, I would like to talk about this function. We have never talked about it. I didn't forget, but I was going to talk about it in chapter 3 anyway, but it appears a little bit in chapter 2. So what I would like to talk about is this limit as x approaches 0 from sine x divided by x. Very important limit, very important function. You will see in a minute why. So I'm going to share my screen because I don't know what this means. Of course, it's 0 over 0, so it's an indeterminate case. I'm going to share my screen, and let's go to the calculator. In y equals, I'm going to clear everything else, and I will just put in sine x, close the parenthesis, and divide by x. And I'm only interested to see this function around 0. I don't care what it does outside of 0. So I'm going to use this viewing window, let's say, from -2 to 2, with a scale of 1, that's okay. And from -2, let's say, to 4, with a scale of 1, and graph. Now, do you think that this function is defined at 0?
No.
Of course not. So second and table, I want to plug in 0, and I'll get the calculator to scream at me. But I don't care. What I care about is the limit. Who cares if the function is defined at that point or not? We are interested in the limit as x approaches 0 from either side, from sine x over x. What is the answer?
It looks like it's 1.
Absolutely. Thank you, Mark. The limit is 1. But this is such an important situation that it needs a lot of explanation. My rectangles are not all equal, but please assume that they are. This answer will always be 1. And let me give you a few examples. If this is x minus 3, and if this is x minus 3, and this is x minus 3, they're all the same, then the limit is 1. But how do I write this? Of course, I'm not going to write that x minus 3 approaches 0. No. I write that x approaches 3. Because, of course, I'm going to move -3 to the other side. It's positive. So as long as this piece approaches 0, and this is the same thing with this piece, and they're all three the same, the answer will always be 1. You can also reverse and have the box and sign of the box in the denominator. They will all still equal 1. So I can also have limit this is still 1. So now I know I have, what is my phone? Okay, I have 5 minutes left, I know. So let's work on a couple of examples. I'm going to choose from this book, and then you'll choose from that book. I'm sure that they are pretty similar. Okay, so let's start with sine 4x over sine 6x. As x approaches 0, sine 4x over sine 6x. And then you'll choose the next one. Okay, so you can say, wait a minute. Well, I mean, how is this related to this? I don't see it. I don't see the box in the denominator. I don't see what this is all about. True, it doesn't seem like it has any connection. Well, it has. So first of all, let's analyze the 4x and the 6x. Do they approach 0? Yes. If you multiply both sides of this symbol by 4, you will get 4x approaches 0. If you multiply both sides of the symbol by 6, of course, 6, or just say when x approaches 0, 4x must approach 0, 6x must approach 0. So for now, I have the box here and the box in sine. But if I don't have a box in the denominator or in the numerator for the sign in the denominator, then I cannot get this 1, famous 1 in this situation. Yes, but I can rearrange this function the way I like it to look like this. And you can say, okay, this is 1 and this is 1, so what did you do? Nothing. True. But here's what I'm going to do now. So what I did, I multiplied this fraction, top and bottom, by 4x. Nothing changed because this is 1. 4x over 4x is 1. What about 6x over 6x? Still 1. But now I have what I want. I forgot, of course, to say 0 over 0 from the very beginning. We have to do that anyway. Good. So now limit as 4x approaches 0 from sine 4x over 4x. Where is this going?
1.
Of course, because I have 4x, and I have the box in the denominator, 4x. Now, a limit of 6x approaches 0 from 6x over sine 6x. Where does this go?
1.
Perfect.
1.
What I have left now is 4x over 6x. Can anyone simplify 4x over 6x and give me the final answer because I'm lazy to write it again? Okay, let me write it again. Because I simplify an x with an x. So what is the final answer?
2/3.
That's it. Any questions?